Hello, IB Environmental students. Today we're going to be doing the DEV, the discussion and evaluation, right after our results and analysis and conclusion section. To be able to do this, we are going to be looking at an exemplar today, which is available on Google Classroom and or Blackboard. So make sure you look at it, and it acts directly through the IB. So thank you so much, IBO, for putting out those exemplars, because we're going to be using them. And please, please, please look carefully, students, because this one is highly marked, and that means it's got really good stuff in it. All right, so discussion evaluation is a 6-point section on the IA. We're going to abbreviate it DEV because that's how the moderators do it. So let's get started. To make sense of this, just know that the first aspect or strand that's going to get 2 marks is the fact that you have to evaluate your conclusion that you started in your results analysis section now with the context of your broader environmental issue. So in order to do that, you have to think back to what was your initial problem, what was your initial predictions or hypothesis back in the context section at the start of your IA. So what I would recommend is pausing here and looking over this exemplar from IB on tropospheric ozone. So this one's pretty strong. Is this really good note from the IB grader that this could have been more specific by saying that the student was from Lima, and that's the location they did their tropospheric ozone experiment. And then if I were to summarize really quick, but I think you should read it yourself, either here or open it up in the PDF form from our website, is that their environmental context is all about tropospheric ozone pollution and photochemical smog, which is a big set of concepts from our class. And whether or not we've got into whatever you're doing in your IA in class, you do need to look ahead or look at what we've already covered and use those big concept words and those big vocab words, because that's what's expected both in those earlier sections of the IA and what we're talking about today in the DEV. The big picture trend that they found looking at what we go over in class is that more traffic is going to put out more chemicals like NOx, it says here, all right, and that's coming out of cars, and that's going to make more tropospheric ozone, which they're measuring. So they're predicting more traffic, more tropospheric ozone, and they back it up here in their initial section. And then they did this big experiment testing it out that you should revisit in the example IA full reading. And their data then show that information. So whatever your data is showing you, we're going to have to make connections back to those sections in the data and in the environmental context section. So we're making a lot of connections throughout the IA in this new section. So let's get ready to connect the data, the conclusion, and that environmental context section. So here in this example, what they find in the graph is that there is a bit of a trend, but as you see, the dots are not along the trend line, so it's not a perfect trend. It would be really an even stronger graph if they actually showed the R-squared correlation value, but if you pause and read the description, they do mention that it's not a perfect trend. So as we talk about their conclusion in a moment, that's an important graph to keep in mind. And so pause here and reread this conclusion, and then let's talk about it. So in this conclusion, they say that they can support their initial hypothesis and big idea concepts from the earlier part of the IA, which is the environmental context section. And so when they're evaluating their conclusion, they can say that it's following those trends. However, they note that although there are large fluctuations, show that there are many uncontrollable factors, and so it was not a perfect conclusion. They cannot perfectly support their initial predictions, and that I can't be perfect. That's where we're humble scientists. So the big idea of this new section is we have to provide specific reasons why our results are not perfectly aligned or similar, and why they might be different from our initial environmental issue concepts or predictions in the background research. So here in this highlighted blue section, they start discussing why there were some differences. Some of that might be how close this person was when they were measuring the traffic. Some of it might be that other weird factors as they were doing the data, and all sorts of different things. Notice they talk about specific tables, specific graphs. They also cite specific data points. So here, let's read what the IB grader says about it. It says the conclusion is being evaluated, meaning they are sense making it. They're saying pros and cons and how it relates to the environmental big picture issue, which for this student, it was tropospheric ozone. For you, it's going to be something else. So they don't, though, evaluate the quality of the traffic or the fact that the traffic was analyzed for a very short period of time of the morning. So it gives no account of big picture traffic problems. So here they're suggesting that if traffic is the IB, they should dig deeper into what they should have expected traffic to be like. So for instance, if you're doing something on water, what do we expect to happen with water pollution? If you're doing something on biodiversity, what did we expect to happen with that based on your prior knowledge from class, your prior research, and why aren't we seeing those trends exactly how we expected? And we have to cite data. Evaluation is pros and cons. And dig deep, make those connections. You are likely to probably use MLA citations here. So that's the first step of the DEV. The next part is talking about strengths, weaknesses, and limitations in your planning, which is what they mean by the method used. So you made a plan of attack and you justified why you were going to do your experiment or research in a particular way, whether it was transects or whatever. This person used these weird strips, right, to measure ozone, which is not the perfect thing. They only changed color and they didn't necessarily start with a numerical piece of data. So they did say that the color changes were consistent, so consistency is good. This is a place where if you have a data-based experiment, which hopefully you do, you would be able to cite your standard deviations again as a strength if they were really low and close to zero. If you had a great sample size and extra data on top of that, 5 levels of IV and 5 trials for 25 or more data points, this is where you get to brag about having tons of data. Wonderful. And anything else that worked really well. But I will say, be careful. We need to have acceptable things. So when we talk about both strength and weaknesses, we want to be specific. So this is from another experiment about heating a can and making a calorimeter, which you may have done back in chemistry class. But it's specific and it's explained. Unacceptable things, whether strengths or weaknesses, are things that aren't explained or aren't specific. So test tubes weren't clean. I didn't have enough time. Human error. I might have messed up. Those are not okay answers. So to get credit here, you have to be specific and be detailed. Every strength or limitation needs a realistic and significant improvement. And when you make those improvements, make sure those improvements are specific and reasonable. So for instance, let's go over what the person here for the tropospheric ozone exemplar that IB put out says. And it's very lengthy, so you might have to pause, and I've used circling to try to highlight some of the stuff that they do, because they got amazing marks on this. They didn't get it perfect on the first aspect, but they did very well here. So when we talk about this, make sure you're thinking about accuracy, precision, and reliability, and here are some good reminders about what that means. So here's what the person says. So they had 7 test areas, which was great amounts of data. However, it would have been better if they covered a larger part of the city, which was their location. And they, remember, we're supposed to really mention that location in their research question. And so when we think about the fact that this is a discussion and evaluation, they now next say, well, guess what? But to do a wider area, I probably wouldn't realistically be able to do that. So this is an evaluation here in orange. How realistic is this solution? So you could come up with a solution, but if it's not realistic, you need to mention it. So they could do this, but only if they got more people to help. And that might have caused some inconsistencies in the data. Another thing, they could have increased the number of strips because they only did 3 strips for data at each location. Now, they overall had sufficient data, and we know that there's the 5 by 5 rule, so it could have been better. And that though they say that there were also other factors other than ozones that might have impacted the chemistry of the color change of the strip. So if they could, they might have wanted to do other things to affect the uncontrollable variables, which they summarize here. Things like making the strips all face the same direction, putting them equidistant from different things. So you might want to pause and read this area over. Another major concern was they only counted cars for 2 minutes, which was a super short time. It would have been better to count cars over 8 hours, which would have been more accurate, but it's super unrealistic, and they would have again had to get more people involved in order to do this. And so a reasonable improvement might have been to count cars for a longer period of time, maybe more like only 1 hour instead of 8 hours. And it would have been better to maybe do rush hour and be careful about consistencies there. Lastly, they also talk about the fact that their strips are qualitative data and it's subjective when you're looking at color measurement. So anybody doing a qualitative data that's converted into quantitative needs to be careful and mention that that's super subjective. And so to do a better job, they might like to do a more quantitative experiment, and so they here are suggesting a realistic next step that could have been a future experiment, which IB loves. This is a really good thing to do, and it gets you loads more points by coming up with a new experiment that you could be able to do. And lastly, of course, having more data, more trials is always better, so it's always a good idea to somehow mention that. It would have been better to specifically say how many more strips they would have wanted to have. Our last section is basically a tie-in to the previous one, and it is summarizing improvements and summarizing what a future experiment would do. So after we have all of those weaknesses, we would like to think about what our future experiment or research would look like. So they say we would have a wider area, but remember that would have required more people, that we would do more data, use more strips. So this is pretty good. I think it would have been even better for them to be more specific, but this got full marks. So that's the discussion evaluation section. Remember, it's very much connected to the previous sections we did. So if you are weak in your data section or you are weak in your context section, you need to go back and edit those previous sections so that they're stronger. Otherwise, this section is going to be horrendous to do. Hopefully you've taken notes on the tips, because in class we're going to be working on this and double checking that we feel confident about our other sections and requesting and advocating for help. Wonderful job, guys. Good work.